Every time I drop a video testing a Linux distro on any hardware, I get flooded with comments asking, but what about Linux Mint? Well, today's the day. I'm doing something I've never done before, building a mini Linux Mint gaming PC, and I'm taking y'all along for the ride, step by step. Let's do this. Hey guys, CJ here with Elevated Systems, and as you can see from the spread of components, we're building a PC today, but not just any PC. I'm putting together a super compact gaming rig specifically designed to run Linux Mint. Now, scratch building a Linux gaming PC, that's something I've never done before. I built hundreds of Windows gaming rigs, and I've built lots of Linux PCs for clients, but those were usually for development or productivity. Because let's be real, until Steam got serious about Proton a few years ago, gaming on Linux wasn't exactly an experience that drew new users to the platform. And I say that as a Linux user and advocate for over 30 years. But things have definitely changed. While some anti-cheat enabled games are still off the table, for the vast majority of titles, the experience is smooth and seamless. So here's the plan for today. First, I'll walk you through each component and why I picked it for the build. Then we'll dive into the assembly process step by step. After that, I'll show you how to download and install and configure Linux Mint. And finally, we'll check out the gaming performance of this beast. Oh, and stick around because I'll be giving away some of the gear on this workbench. You won't want to miss out on that. Now let's talk component selection. I've got to start with the case because it really set the tone for the rest of the build. When you're putting together a Linux Mint PC, what better enclosure to use than the Fractal Terra in Mint Green? Okay, it's technically Jade Green, but let's be honest, true Mint Green isn't exactly a winning color for a PC case. The Terra in Jade, though, it's a gorgeous case, super versatile when it comes to component selection and easy to work in. Now, while the small form factor case influenced the build, I had a few other goals in mind when picking the parts. First, I wanted to build a strong mid-range gaming PC capable of delivering high frame rates at 1080p and holding its own for those looking to step up to 1440p. Of course, the components needed to play nice with Linux, and I aimed to keep the total budget under $1,500. And I know some of you are thinking, $1,500 for a mid-range gaming PC? That's nuts. Unfortunately, that's where we're at in 2024. So let's dive into the core of the build. And if I'm being honest, for Linux, the most compatible platform is Intel, and the best sub $300 gaming CPU is the Intel i5-13600K or 14600K. But until Intel updated microcode has made its way to every LGA 1700 platform and proven to be stable, I can't recommend them. Plus, LGA 1700 motherboards are at the end of their life with Intel's 14th gen CPUs. So for this build, I'm going with the AMD Ryzen 5 7600. Now, this is actually 7600X, but don't worry, I'm turning it into a non-X 7600. As a small creator, I bought all of the stuff out of my own pocket, and I had the CPU on hand. I did have the new Ryzen 5 9600X on order, but after watching all the reviews, it turns out the performance gain is minimal at a significantly higher price. If you want to spend an extra $100, I'd recommend the Ryzen 7 7700X. But at the sub $200 price point, nothing beats the versatility of the Ryzen 5 7600. Now, the 7600 non-X does come with a very capable stock cooler. If you're looking to save some money, you can stick with the stock Wraith cooler, but for continuous gaming loads, I wanted something quieter and with better cooling capacity, so I'm going with the Noctua NH-L9x65 low profile cooler. For the motherboard, I'm using the MSI MPG B650i Edge Wi-Fi Mini ITX. The selection of Mini ITX AM5 motherboards is limited and ranges from around $130 to over $400. The MSI board sits in the middle at about $280 and offers a great balance of features and ease of use for this build. It also includes a few UEFI options for simple one-click CPU tuning and ultravolting. However, like all AMD motherboards, it comes with a MediaTek Wi-Fi adapter, which still struggles with some Wi-Fi 6E access points despite several updates and patches. The good news is that MSI uses an M.2 Wi-Fi card located under the main heatsink, so if needed, you can swap it out for a more compatible Wi-Fi adapter like an Intel AX210. For memory, I've got 32GB kit of Corsair Vengeance DDR5 6000. Its low profile hits the 6000 megatransfers per second sweet spot for Ryzen CPUs and is very affordable and sports a low cast latency of just 30. For storage, I'm using a 2TB Crucial P3 Plus Gen 4 NVMe M.2 SSD. There is a second M.2 slot on the back of the motherboard, which can be easily accessed even after the build is complete if you want to add more storage later. The Fractal Terra only supports SFX power supplies, so I'm going with the Corsair SF750. It's modular, has short-sleeved cables, and has been my go-to PSU for small form factor builds for years now. Finally, the graphics card. You can use pretty much any GPU with Linux, but in the spirit of free and open software, I'm going with an AMD card. AMD has been open sourcing their drivers for years, and while NVIDIA has started to do the same, you'll still need to install their proprietary game-ready drivers on Linux. For this build, I'm choosing the ASRock Challenger Radeon RX 7700 XT. This card is just slightly wider than 2 slots, giving me plenty of room to fit the 65mm CPU cooler on the other side of the case. Most importantly, it meets my requirements for great 1080p gaming performance and solid 1440p performance, all while hitting our price point. Since AMD priced the 7700 XT so close to the 7800 XT when it launched last year, most people just spent the extra $50 for the better card. This allowed the 7700 XT to drop in price over the past 11 months, while the 7800 XT hasn't, making this card a much better value now. I do have a couple more optional parts for this build, but as of filming, the total cost comes to $1,465. We're going to start the build by getting the case ready. First, remove the external panels, pull the tab to the rear, sliding the top panel back, and lift to remove. Open each side panel and release it by sliding the hinge lever back and sliding the panel off. Next, remove the graphics card riser and bracket by taking out the 2 thumb screws below the riser and the 1 screw on the rear of the case. After that, remove the 4 orange plastic transport tabs. Slide the middle spine over to the position number 2 and secure it by replacing the 4 screws. Finally, you can optionally install a bottom-mounted fan below the PSU position. I'm using an Arctic P12 Slim along with a fan grill I 3D printed. I tested the build with the fan as both exhaust and intake, and while the GPU temp was slightly lower with the bottom intake fan, there was no significant difference compared to not having the bottom fan at all, so this step is completely up to you. Next, unpack the power supply and grab the 24-pin ATX cable, one 8-pin CPU cable, and one 8+8-pin PCIe cable. Plug each of the cables into their corresponding connections on the PSU. Using these 4 screws from the case accessory box, screw the PSU into the case with the fan facing out. Let's get the motherboard ready for install. First, remove the stock cooler mounting brackets. Next, lift the CPU socket mounting arm and socket cover. Line up the triangle on the CPU with the one on the socket and carefully place the CPU in the socket, ensuring the notches line up with the tabs. Gently lower the tray cover and lock it in place with the locking lever. The plastic cover will pop off on its own. If not, just remove it. Optionally, you can replace the stock CPU mounting bracket with a Thermalright CPU holder frame. To do this, first familiarize yourself with the CPU orientation in the socket. Then, using the included driver, loosen the 4 Torx screws holding the stock CPU bracket on. Those are captive screws, so loosen each a few turns at a time until you can lift the bracket off the motherboard. Next, carefully place the CPU in the socket and position the frame over the CPU. Using the screws that came with the CPU holder, screw down the holder, turning each screw a few turns and alternating corners until all are snug. Next, using a number 0 Phillips head screwdriver, unscrew the 2 screws holding the M.2 heatsink cover on. To install the SSD, insert the drive into the M.2 slot at about a 30-degree angle, hold the SSD down and secure it in place. The screw can be found in the motherboard box, or the Crucial P3 Plus also includes one in the box. Reattach the M.2 heatsink. Whichever method you use to secure the CPU, attaching the cooler is the same. Find the AMD components in the cooler accessory box, place the 4 standoffs over the open screw post where the stop cooler bracket was attached, place the brackets over the standoffs so they curve towards the CPU, and secure them in place with the screws. Now place a 3 to 4 millimeter glob of thermal paste in the center of the CPU, unclip the fan from the heatsink, line up the screws on the heatsink with the mounting posts, and attach the heatsink, alternately turning the screws a few turns at a time until they're snug. To install the RAM, line up the notch on the RAM with the tab in the DIMM slots, and using equal pressure on the outside edges of the RAM, firmly press the RAM into the DIMM slot until it clicks in place. Clip the fan back onto the heatsink. On the top corner of the motherboard, you'll find 2 4-pin fan headers. Plug the CPU cooler fan into the inner header. Now we're ready to install the motherboard, which actually installs upside down in the Fractal Terra. To make things easier, before lowering the board into the case, plug the CPU power cable into the connector located in the corner just above the CPU. Locate the 4 mainboard screws in the accessory box, lower the board into the case, lining up the mounting holes with the standoffs, and screw the board into place. It's time to install the graphics card. First, in the same manner we installed the RAM, line up the notches and firmly press the card into the PCIe riser until it clicks into place. Now position the card and bracket in their spot in the case, but before screwing it back in, plug the other end of the riser cable into the PCIe slot on the motherboard. Now you can secure the 2 thumb screws on the bottom of the bracket and the 1 screw on the rear of the case. Finally, plug the 8+8 cable into the supplemental PCIe power connectors on the top of the card. Now it's time for the fun part, cable management. We do have a few more cables to plug in, but cable management is as much an art as it is science. So I'm just going to show you where they plug in. At what point in the process you plug them in is up to you. If you install the case fan, there are 2 fan headers you can use, the one next to the CPU cooler fan or another further down the board. It doesn't matter which one you use, we'll set their behavior in the UEFI later. The front panel connector will only be used for the power switch cable, which plugs into these 2 pins. Next, the large 19-pin USB cable plugs into the header on the outside edge of the board, and the USB 3.2 cable plugs in next to it. Finally, there's the 24-pin ATX cable. Now, the only task left is to manage and tie down the cables as best as possible. If you don't go with a case fan, the job is easier since you have room under the PSU for excess cables. Because I did have a fan there, my task was to keep it as open as possible, so I tightly tied all the cables between the motherboard and the PSU. Zip ties are your friends here, so having more on hand than the few that come with the case can be helpful. Once you're satisfied with the cable management, it's just a matter of reattaching the 3 case panels. Just be sure the power supply switch is on before closing up the top, although the Terra makes getting to the switch very simple. And that's it. We built a mini ITX PC, so now let's get it configured, get Linux Mint installed, and see how it performs. With the PC plugged in and connected to peripherals, it's time for the first boot. You should be met with this screen, and hitting F1 will take you to the UEFI menu. From there, pressing F7 will bring you to the advanced menu. We'll start in the settings menu, and under save and exit, make sure to restore the motherboard to its default settings just in case. Next, on the OC tab, enabled XMP to ensure we get our full memory speeds and timing set. Now, since I'm using the Ryzen 7600X with its hefty 105 watt TDP, I want to undervolt my CPU, and MSI makes this easy. Under Advanced CPU Configuration, click Config TDP and select the 65 watt option. This essentially turns my 7600X into a 7600. If you're using the 7600 Non-X, you shouldn't need to tweak it, but if you do find your CPU thermally throttling, you can set a thermal limit to automatically undervolt it. You'll find this option in the same menu under AMD overclocking, select Precision Boost Overdrive, and here you can set a thermal limit of 85 degrees. Of course, you can always dive into the advanced options and manually configure the voltage curve of your CPU for an optimal balance of thermals and performance, but I found the one-click options work really well. Before exiting the UEFI, I took some time in the hardware monitor tab to tweak my fan curves. I increased the fan step up and step down times and set a more moderate curve for the CPU fan. If you plug the case fan into the header near the CPU like I did, you'll need to adjust that as it's set to 100% by default. Enabling smart fan mode and setting a slower, quieter curve that matches the fan at 70% will help keep the noise down while still pushing some hot air out of the top of the case. Now, just save and exit and the PC is ready to get minty. You will need access to another computer because the first step of installing Linux Mint is to download the Linux Mint 22 ISO. I'm going with the Cinnamon edition, which is Mint's custom desktop environment and one of the reasons it's so popular with new Linux users transitioning from Windows. You'll also need an app that can create a bootable USB from the ISO. For this demo, I'm using Belenia Etcher, so you'll need to download and install that app as well. Once the ISO is downloaded, insert at least an 8GB USB flash drive, launch Etcher, select the Mint ISO, choose your USB media, and click Flash. This process takes several minutes, but once it's complete, you're ready to install Mint on your new PC. Insert the USB drive into the PC and power it on. If you're met with this screen again, just hit F1 to go to the Settings tab, and under Boot, select your USB media as boot option number 1. Save and reboot, you should see this menu. Hit enter to select Start Linux Mint Cinnamon 64-bit. After about a minute, you'll boot into the Linux Mint Live environment. Now you're running a complete version of Linux from the USB flash drive. Here you can explore the desktop and apps. I immediately tried connecting to the Wi-Fi and was thrilled to find the MediaTek adapter worked without any issues. Once you've explored enough, it's time to install the operating system. Double-click the Install Linux Mint icon and the installer will launch. From here, it's pretty straightforward. I recommend installing the third-party codecs and enabling secure boot. In the next step, if you're starting with a blank SSD, you can simply select Erase Disk and install Linux Mint. If you have another operating system like Windows already installed on the disk, you can choose to install Mint alongside for a dual boot or multi-boot system. From this point on, everything is simple and self-explanatory. Once the installation is complete, the system will reboot and you'll be up and running with Linux Mint. Mint is a very beginner-friendly distro. You can update the system, install software, and manage settings all through graphical user interfaces, just like someone moving from Windows would be used to. However, I highly encourage new users not to be intimidated by the terminal. It makes things easier and unlocks the true power of an open source operating system. In just a few minutes and using only the terminal, I updated the operating system and all the installed software packages. I also installed system monitors and testing packages like Geekbench 6, which I ran in the terminal while monitoring system specs and temps to ensure everything was working properly, and it was. For heavy multi-core workloads, CPU temps peaked in the mid to upper 80s, and the system remained completely stable. But this PC was built to game, so let's complete the theme and dive into some gaming. Despite the ultra-wide 3440 by 1440 resolution, even on high settings, I was getting impressive average frame rates on some demanding AAA titles. I had a blast gaming on my new mini mint rig. I had no issues installing or running the half dozen games which I tested. Even Helldivers 2, which has given me trouble in the past, launched and ran smoothly. That said, gaming on Linux isn't without its quirks. Some popular titles like Fortnite, Valorant, and Call of Duty Warzone are currently a no-go due to anti-cheat restrictions. Just something to keep in mind if you're thinking about making the switch to Linux. And finally, if you're considering making the move to Linux, I've got something to help get you started. I'm giving away this beautiful Jade Green Fractal Terra case, along with the mint keycap set I used in the video and the matching leather desk mat. No, it's not the entire PC, I know, but if you hit that subscribe button and help me reach over 100k subs, maybe PC giveaways will be a thing. In the meantime, smash that like button and drop a comment below listing the specs of the PC you'd build in the Fractal Terra if it was yours. Be sure to do your homework though, because I'll pick the build that's compatible and that I like the best, and I'll reach out to send you the case. Good luck, and I'll see you in the next one.